Alright, I'm going to use this skateboard simulation to introduce energy. You've probably heard about potential and kinetic energy in the past, so I just want to show you what it looks like in the simulation. So here's this dude on the skateboard, and he's free to move around if he wants to, but he's sitting still, right? And so right now he has no energy, we would say. There's no potential energy, and there's no kinetic energy. Potential being the potential to move, and kinetic being actually moving. But what I can do is I can click on this little dude and lift him up in the air, and now I've given him some potential energy, right? In this case, gravitational potential energy. And the height that I've lifted him tells me how much energy I've given him. That means if I let him go, boom, he's going to move, right? Because I give him the potential to move. Now what's cool about the simulation is I can actually see the energy I'm giving this guy. So if I were to just set this track here, this is like a little floating track in the sky, and I turn on this bar graph, right, which I'll clear out, you can see this shows energy. It shows kinetic energy, potential energy, thermal energy, which is really what they're just calling friction, and the total energy. So we're really only interested in kinetic, potential, and the total. So if I were to lift this dude up, I'm giving him, you can see, potential energy, which means that my total energy, all the energy I have, is just the potential energy. Alright, so that's kind of cool. I can see that. And if I were to lift this whole thing up, whoa, 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 if I lift it up higher, whoa, he gets even more potential energy. Okay, so I'm going to reset this. Now, there's also kinetic energy, and I can use the track to give this skater a little bit of kinetic energy, right? Energy of motion. So I'm going to put the skater up here, and now I can see him sliding along. Alright, now he's moving, so he has kinetic energy. Now again, I'm going to turn on the bar graph, and we could reset that, and let the skater go. And you see, he's got kinetic energy now because he's moving at a constant speed, and a little bit of friction there too. Alright, let me show that one more time. So he's got the kinetic energy because now he's moving, and off he goes. Okay. Now what's really interesting about this stuff is that we can get the conservation of energy, right? So that we know that energy can't be created or destroyed, so it has to just change forms. And so what we can do is relate this kinetic energy to potential energy. So let's just say I make a big track here and send this guy out shooting down the track. Now at the very start, let's see, how should I do it? We'll do it that way. At the very start, I'm giving him just potential energy. He's not moving at all, right? And by the end, he's back at the ground and he's moving quickly. So he's lost his potential energy and it's all kinetic. So what I'd like you to do is just watch our energies here, right? I'm going to start by giving him all potential energies. So you see that the total energy is equal to potential. As I let him go, we're going to see that that potential energy starts to decrease while the kinetic energy is increasing. But look at the total. It's not going down at all. It's staying perfectly still because the amount I'm losing of potential energy is all going into kinetic energy. And by the time I reach the bottom, my potential energy is 0, and my kinetic energy is all the energy there is. Although you saw there's a little bit of friction. Again, this is a little particular, so as soon as it hit the ground, it added friction to it. But see, the total energy, even including friction, is the same. Alright, so this is kind of cool. We can see this, and in fact, I can just get rid of the track altogether and just lift this guy straight into the air, give him potential energy, and watch that potential energy turn to kinetic, and then all to friction at the end. Now I want to show this to you one other way, and that is with a swinging pendulum. So this is just a simulation of like a string holding a heavy weight, and you can drag that weight off to the side and let it swing back and forth and back and forth. Now, there's energy involved in something like this as well, right? You can see it's obviously moving back and forth, but it's going up and down in space, right? So it's at 100, 120, 140, 160. It's going down, back, up. Okay, so we're seeing the transfer back and forth of kinetic to potential to kinetic to potential. And we can illustrate that, again, by looking at the energy. Whoa, it's off the charts. Let me make this thing not go so far. Okay, so we'll lift him up to here. Okay, cool. So now you can see it's moving really fast. I'm going to slow it down a little bit more. Boom. Okay, at the top, it's all potential. Now it's starting to move So it's getting some speed, and at the bottom, we say the potential energy is 0, and it's all in kinetic energy right there. Boom. And then as it starts to go back up, it's slowing down, so it's losing kinetic energy, and it's increasing in potential energy. But you see that the total is staying a constant. It's just being transferred back and forth between the two. Okay, so in these next two sections, we're going to be learning about how to calculate potential energy, how to calculate kinetic energy, and then we're going to see in section 8.4 how the conservation of energy allows us the energy to go back and forth between these two. Cool. So hopefully you can keep these visuals in mind as you're reading through the textbook.